Welcome back, everyone. I hate to have made this into a two-part video, but I was introducing a lot of topics in the last one, and it was starting to get a little long, so I figured I would split it up in between two videos. But continuing where we left off, we're going to be using the results that we proved in the previous video to prove the power rule. All you have to remember is that the derivative of e to the x is equal to e to the x, and the derivative of the natural log of x is equal to 1 over x. And again, we showed this in the last video. Now we're going to be combining these results with the chain rule to finally prove the power rule. To begin, we write x to the n equals x to the n. I think we can all agree that this makes sense. But the important part comes in taking the natural log of both sides. The natural log of x to the n, again, this is a logarithm rule, so I'm assuming you already knew this. You have the exponent n in the input, so you can take it out and have n natural log x. Now, what we do is we raise both sides to the e power. Now, since this is log base e, raising e to that power will cancel out the logarithm. And now, what we have is x to the n equals e to the n ln x. Now, from here, we will be finding the derivative of x to the n using the chain rule. What that looks like is recognizing that this is a composite function. Our f of x is e to the x, and our g of x is n natural log of x. As we can see, if we have f of g of x, we get this expression on the right. This means that the derivative of these two functions must be equal since they're the same function and they're not off by any constant. Now, what this means is that once we find the chain rule derivative for this right side, we will naturally get the derivative for x to the n, and we'll be able to prove the power rule. Now, because of the chain rule, we know that we can simplify that derivative of f of g of x into f prime of g of x times g prime of x. Now, f prime of x is e of x because f of x is e of x, and f prime of x is still going to be e to the x. That's what we showed earlier. Which means that this is going to stay the exact same. We have e to the n ln x, and then times g prime of x. Now the derivative of n ln x, since we're differentiating with respect to x, n is just a constant, and that can be multiplied outside the derivative. And of course, the derivative of ln x, as we showed in the previous video, is 1 over x. So we get n times 1 over x. Now, what this means is that we can rewrite the derivative of x to the n as n over x times e to the n ln x. But remember that e to the n ln x, bring down the n over x, is e to the ln of x to the n. And of course, this e and this ln will cancel, and we get n over x times x to the n. What this means is that we can finally simplify. This over x will subtract 1 from the power of this x, right? You divide by x, you're going to be multiplying by x to the negative 1, add the powers. And we're left with n as the coefficient. But this is, of course, equal, again, to the derivative of x to the n. And so we've shown for every x to the n, where n is any real number, the derivative of it will equal n times x to the n minus 1. There's plenty of ways to prove it for positive integers, negative integers, rational numbers, but this is the proof for all real numbers. I hope you were able to enjoy and understand this explanation and proof, and thank you so much for watching.